Hello students, we will continue with the miscellaneous exercise. Yesterday we have done until 7th question. So we will start with question number 8. Question number 8 says, show that A is nothing but A intersection B union A minus B, and A union B minus A is A union B. These two we have to prove. So first we will prove A is A union B union A minus B. I'll start with let X belongs to A. When X belongs to A, we have to show that X belongs to A intersection B union A minus B. This is the first thing we will be proving now. A intersection B union A minus B. Okay, we will start with X belongs to A. Now, if I say X belongs to A, that implies X belongs to A minus B. That's clear. Similarly, if X belongs to A, we can say X belongs to A intersection B if X belongs to B. So, we are taking X belongs to B. In such case, X belongs to A intersection B. So from these two, we can say X belongs to A intersection B union A minus B. This is how we have proved. Coming to the second one, we have to show that A union B minus A is equal to A union B. So if we take X belongs to A union B minus A, we have to show that X belongs to A union B also. So when I say X belongs to A union B minus A, that means X belongs to A or X belongs to B minus A. That means X belongs to A or X belongs to B. And so we can say X belongs to A union B. That means we have shown that A union B minus A is same as A union B because we started with this and ended with this. Now in the same way, question number 9 also says, show that A union A intersection B is equal to A intersection A union B is equal to A. So you can prove this first one, A union A intersection B equal to A. So first of all, we can use distributive law. We can say A union A intersection B. So we have to show this, show that. Or we can say, we are just modifying the question and saying show that this is equal to A. Now, A union A is A. Union A intersection B. Now, A and A intersection B, if you take union, obviously you will get A. This is the first way, an easy way to prove using distributive law. Okay, second one. Show that A intersection A union B is equal to A. Again, we will use distributive law. A intersection A intersection A intersection B. I'm using distributive law here. Intersection will distribute. So I will have A intersection A. Union A intersection B. Now A intersection A will be A only. Union A intersection B, as we got above. This is A only. And hence it is proved. Let's go to question number 10. Show that A intersection B equal to A intersection C need not imply B equal to C. For this, we can take one example. Let A be 0, 1, B be 0, 2, 3, and C be having 0, 4, 5. Now, A intersection B is just 0. Then A intersection C, this is also 0. So we have taken A intersection B same as A intersection C. But did you see B and C are not equal? This is what we are showing. Coming to question number 11. A and B are two sets. A intersection X equal to B intersection X equal to 5. And A union X equal to B union X. Show that A equal to B. This is what they are asking. So you can do this in many ways. One of the ways we can do is, we have already proved in the previous questions, A is nothing but, previous question, A intersection A union X. That means this I can write as A intersection. Instead of A intersection X, I can write B intersection X. And instead of A union X, I can write B union X. So A union X, I will write it as B union X. B union X. This I will write it as A intersection B union A intersection X. Using distributive law. And this I will write as A intersection B union, because A intersection X is given as empty set. So this will be nothing but A intersection B. This is what we got. Similarly, B, in the previous question, we have shown B is B intersection B union X. So now I will write B intersection B union X. I will write as A union X. So this will give me B intersection A union B intersection X. This is nothing but B intersection A union empty set, because B intersection X is given as empty set. This is nothing but B intersection A, which is nothing but A intersection B. So we can say that A and B, we are getting same answers. A is equal to B. That's it. We have proved it. Let's go to question number 12. A, B, C are three sets. A intersection B, B intersection C, A intersection C. All the three are non-empty sets. Then show that A intersection B intersection C equal to 5. So what I will do is I will take A as 0, 1, B as 1, 2, and C as 2, 0. So A intersection B, we have 1. B intersection C, we have 2. And A intersection C, we have 0. So as per the question, we have shown that A intersection B, B intersection C, A intersection C are non-empty. We have proved because it's given. Now we will find A intersection B intersection C. Nothing we can find. That is, we got this as empty set. Okay, let's go to question number 13. Let us take a school by universal set. In universal set, total 600 students are there in a school. Let us take the circle T. T means students who are taking T. So number of students taking T is given as 150. Let us take another circle C. C means students who are taking coffee. It's given that number of students taking coffee are 225. Now number of students taking both tea and coffee. T intersection C means taking both tea and coffee. That is given as 100. They're asking how many students take neither tea nor coffee. What do you mean by neither tea nor coffee? The students are not in the circles at all. They are not taking tea. They are not taking coffee. So this is what they are asking. Number of students taking neither tea nor coffee means they are completely outside T union C complement. This you have to find. So this says taking neither tea nor coffee. So how will you write union C whole complement, T union C? You have to write T complement intersection C complement. Now how will you write number of students T complement intersection C complement? How to find? This is very difficult to find. So what we will do is, first we will find N of T union C. Complement we will find afterwards. N of T plus N of C minus N of T intersection C. N of T is 150, N of C is 225 minus 100. So we are getting 275. But N of T union C whole complement will be, from universal, you have to subtract N of T union C. Universal set has 600 minus 275. That means 325 students take neither tea nor coffee. Coming to question number 400. There is 14th. Question number 14. There is a group of students. In this group of students, circle H represent students who know Hindi. So number of students who know Hindi is 100. Next, the circle E represents the students who know English. So number of students who know English is 50. Number of students who know both Hindi and English. So this means know Hindi and English both. That is given as 25. Now each of the students know either Hindi or English. That means the students must know either Hindi or English or both. No other option. That means here universal set is nothing but H union E. So how many students are there in the gap, in the group? You have to find universal set. That means N of H plus N of E minus N of H intersection E. That means 100 plus 50 minus 25. And that will be 125. So total number of students in the group are 125. Next, 15th. In a survey of 60 people, total 60 people are present. U is equal to 60. It was found that 25 people read newspaper H. So H is the newspaper H, name of a newspaper. So number of people reading newspaper H is 25. There is another newspaper T. Number of people who read newspaper T is 26. And there is another newspaper I. So number of people who read newspaper I is also 26. Next, number of people who read both H and I. So this represents both H and I, which is given as 9. Number of people who read both H and T is given by 11. Number of people who read both T and I is given as 8. And number of people who read all the three, H intersection T intersection R. That means read all three newspapers. That's given as 3. First, you have to find number of people who read at least one newspaper. At least one. H union T union I. This represents those who read at least one newspaper. That means they may read one paper, two papers, or all the three. Any one paper, any two papers, all the three papers. Right, that. So that you have to find. And number of people who read exactly one newspaper. Second one is people who read only H only. Or people who read only T. Or people who read only I. These two you have to find. So first N of H union T union I is N of H plus N of T plus N of I minus N of H intersection T minus N of T intersection I minus N of I intersection H. That plus N of H intersection T intersection I. So N of H is 25, N of T is 26, N of I is 26, minus N of H intersection T is 11, minus N of T intersection I is 8, minus N of I intersection H is 9, plus N of H intersection T intersection I is 3. Put all the given information. And this will be equal to 80 minus 28, that is 52. Coming to the second one. Suppose if this is A, this side is B, C, and D. Here E, F, G. So if I want second one, I have to find H only plus T only plus I only. This is what I have to find. So how will I find this? From N of H, I have to subtract some things. What are they? N of H intersection T, N of H intersection I, and N of H intersection T intersection I. This is what I have to subtract. Similarly, for F, I will take N of T. From this, I will subtract N of H intersection T, then N of T intersection I, and then of N of H intersection T intersection I. Next plus, now from N of I have to subtract N of T intersection I, N of H intersection I, and N of H intersection T intersection I. But I have to make some changes here. Because when for instance, for the first one, talking about the first one, if I want only H, so from H, I will be subtracting this intersection and this intersection. That means I'm subtracting this A part 2 times. But I have to subtract only one time, not two times. So I will be adding one time. So I will not subtract this from the brackets. I will remove it. I will add only one time. Is that clear? So the same thing I will follow for the remaining. This I will remove from brackets because I'm not subtracting. I'm adding it one time. I'll continue here. So first I will have n of h 25 minus n of h intersection t is 11 plus n of h intersection I is 9. To that you have to add n of h intersection t intersection I, that is 3. Then second, n of t. N of t is 26. From this you will subtract n of h intersection t, that is 11, plus n of t intersection I, that is 8. Plus the third one, n of I is 26. From this you will subtract n of t intersection I is 8, n of h intersection I is 9, and then you are adding n of h intersection t intersection I. Here I forgot to add 3. So that means I will have 25 minus 20 plus 3 plus 26 minus 19 plus 3 plus 26 minus 17 plus 3. All these I have. 25 minus 20 is 5 plus 3. 26 minus 19 is 7 plus 3. 26 minus 17 is 9 plus 3. 8, 15, 18, 27 plus 3. 30 people. Total, we have 30 people who read exactly one newspaper. It's difficult to understand, but you can clearly see the work and then follow. Next is question number 16. In question number 16, in a survey, it was found that there is a survey. 21 people liked product A. This is product A. So A is a product. Like that, B is also a product. And C is also a product. So number of people who like product A is 21. Number of people who like product B is 26. Number of people who like product C is 29. Then number of people who like both A and B product, 14. Number of people who like both C and A products, 12. Number of people who like both B and C products, 14. And number of people who like all the three is 8. How many liked product C only? So they are asking C only. This. So if this is A, this is B, and this is C. Or if this is P, this is Q, this is R. Like this also you can take. So from N of C, you have to subtract n of A intersection C and subtract n of B intersection C. But in that process, this Q is getting subtracted twice. You have to subtract only once. So you have to add A intersection B intersection C. So n of C is 29, n of A intersection C is 12, n of B intersection C is 14, and n of A intersection B intersection C is 8. So 29 minus 12 is 17 minus 14 plus 8. That is 3 plus 8. And so 11 students or 11 people liked only product C. So with this, we have completed completely the lesson sets. In the lesson sets, particularly miscellaneous examples and exercises also we have completed. So doing K-set problems will be very easy. At the end of your textbook, there is summary. Summary is given. Whatever you have learned in these sets, that summary is given. I will paste that summary so that you will learn. Just give me some time. I'm pasting that summary to you. Just a few minutes. I have already saved it in my computer. I'll just open it, copy and paste. Those who don't have textbook, they can go through this, which I'm pasting. If you learn summary every day, it will be easy for you. That means you will remember whatever you have learned in this chapter. Not only that, whatever problems we have learned, that you have to go through again and again. Every day you have to learn. I'm reaching WhatsApp. I'm trying it. But I think I'm not able to reach. So I will try another way. If I'm not able to reach it. No, I'm not able to reach my WhatsApp at present. So let me share it with Skype. Maybe Skype will open. Yes, most probably Skype will open. But it's taking time. Yes. So this is from your textbook, the entire chapter summary. For MSET, it will be very useful. I'm pasting here. One more also I will paste. This is the thing I want to paste here. Okay. So I have pasted this important points from the summary and this important points from the summary. Go through it every day. Not only this, the entire chapter you have to revise very often. So we have still time, I believe. Yes, we have another 20 minutes left. So we can start the second chapter, because after completing this chapter, we can't go to KSET now itself. In KSET, 3 topics we are taking combined: sets, relations, and functions. So, first we will learn this chapter also, the second chapter, that is relations and functions. Once we finish this second chapter also, then we will go to KSET. Meanwhile, you don't forget, you have to revise every day whatever you are learning. Okay, so now we will learn this new chapter, relations and functions. First of all, we have to learn Cartesian product of sets. Cartesian product of sets means you will be given 2 sets. Like set A is having red and blue colors. Set B is having the letters B, C, S. Now A cross B, that is called Cartesian product of sets. That means in A cross B, we will be writing ordered pairs. We will be writing ordered pairs. In ordered pairs, what I will write? I will take different combinations. First, because I wrote A, so first from A, I will take red. Now from A, when I am taking red, I have to take from B also. I have 3 options. From B, I can take the letter B or the letter C or the letter S. In this way, I made 3 ordered pairs. Similarly, I can make 3 more ordered pairs. From A, I will select blue and write first, blue color. So when I write blue color, I have 3 options. Clearly you see, from A, I have taken blue color and written here. So the three options are for the B part. I can write B, or I can write C, or I can write S. So these are the possible ordered pairs I can make and make it as a set that is only A cross B. I can write or represent it diagrammatically also. There is another way to write diagrammatically. How? I will take red color and blue color dots here, which are there in set A. And here I will take letter B, letter C, letter S, which are there in set B. Now, with red, I will have these three combinations with red. And with blue also, I will be having these three combinations. Combinations means like this ordered pairs. Red and B. This one. This dot represents red and B. This dot represents red and C. This represents red and S. This represents blue and B, blue and C, blue and S. R means red. Instead of writing red, I have written in short. B means blue. Instead of writing blue, I have written in short. So that diagrammatically also I can represent. But the Cartesian product of sets is defined. How it is defined? If I have to write A cross B, that means I have to write ordered pairs A comma B, such that A, I have to take all the A's I have to take from set A, all possible ways, and all the B's, possible B's, I have to take from set B. This is the definition of Cartesian product. Similarly, let us take one more example. A is the set having DL. DL means Delhi in short. MP. MP means Madhya Pradesh in short. And KA. KA means Karnataka in short. Now, B is another set. These represent codes. Codes for license plate 01, 02, 03. These all are codes for license plates of vehicles. Then, if the three states, Delhi, Madhya Pradesh, and Karnataka, were making codes for license plate of vehicles, with the restriction that the code should first begin with set A and then end with set B. That means, how will you write the code? First, you will write state and then the number. Like this, you have to make a code for license plate of vehicle. So how many ways it is possible? For that, you have to take A cross B. DL can go with 01. DL can go with 02. DL can go with 03. Similarly, MP can use 01. MP can use 02, MP can use 03. KA can use 01, KA can use 02, KA can use 03. So total these are the possible combinations. One thing you can observe here, number of elements in set A is 3, number of elements in set B is 3. What is the number of elements in A cross B? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it it? Okay. One more example we will take. A is a set having A1, A2. B is a set having B1, B2, B3, B4. Now you have to find A cross B. So what are the ordered pairs you will make? With A1, you can take B1, A1, B2, A1, B3, A1, B4. With A2, you can take A2, B1, A2, B2, A3, B3, A3, B4. Sorry, A2. A2, B3, A2, B4. Because A3 is not there. With A2, you can take A2, B1, A2, B2, A2, B3, A2, B4. These are the possible things. If number of elements in set A is 2, number of elements in set B is 4, number of elements in A cross B is 8. So we can make one rule. If number of elements in A is M, number of elements in set B is N, the number of elements in A cross B will be M into N. 2 into 4, 8. Previous one, 3 into 3, 9. This is how we can make a rule. Suppose, if another example I will take. If I take A as A1, A2, again I will take A only, A1, A2. Then I can find A cross A. How? A1 will join with A1, A1 will join with A2. Then A2 will join with A1, A2 will join with A2, like this. So here number of elements in A is 2, number of elements in A is 2. So number of elements in A cross A will be 2 into 2, that is 4. Like this also we can take. Suppose if you want to find A cross A cross A, that means you will have the elements A, B, C. The ordered pair we can't say here. We have to say ordered triplet. This is ordered triplet. Whereas this we can call as ordered pair. Pair means 2. Triplet means 3. Such that all the 3 A, B, C belongs to A, but you have to take different combinations. So now we can start problems based on this. At the most, around 6 problems we will try to do. First one is, if x plus 1 comma y plus y minus 2 I will take. For a change, y both plus. 1 minus I will take. Y minus 2 equal to 3 comma 1. You have to find what is x, what is y. It's very easy. Because both the ordered pairs are equal, you can set these two equal. You can set these two equal. X plus 1 equal to 3, y minus 2 equal to 1. That means x is 3 minus 1. That means x is 2. Here, y is 1 plus 2. That means y is 3. This is how we found x is 2 and y is 3. Let's go to second question. If P is having A comma B comma C, three elements, Q set is having R, we have to find P cross Q, Cartesian product. Don't say P into Q, say P cross Q. And we have to find Q cross P. When we find P cross Q, we will start with P. AR, BR, CR. And when we find Q cross P, we will start with R. RA, RB, RC. Did you see? For P cross Q, I took AR, BR, CR, starting with P. But for Q cross P, I took RA, RB, RC. That is the difference. We will go to, before going, I want to tell you one thing. P cross Q and Q cross P, are they looking same? No, they are not same. Okay, now we will go to question number 3. A is the set having 1, 2, 3. B is the set having 3, 4. And C is the set having 4, 5, 6. First one, we have to find A cross B intersection C. So A is 1, 2, 3 cross B intersection C. The common in B and C is only 4. So when I take cross, I will start with 1, 2, 3s. 1, 4, 2, 4, 3, 4. This is the answer. Second one, I have to find A cross B intersection A cross C. So first I will find A cross B. I will start with A. 1, 3, 1, 4. Then with 2, 2, 3, 2, 4. With 3, 3, 3, 3, 4. This is A cross B. Intersection. Now A cross C, A and C. But I will start with A. That means I'll start with 1. 1, 4, 1, 5, 1, 6. Next with 2. 2, 4, 2, 5, 2, 6. Next with 3. 3, 4, 3, 5, 3, 6. Now I have to take intersection. Common. Common in both. What can you see common? 1, 3. Can you see common in both? No. 1, 3 is not common. So I can't take 1, 3. What else common? Yes, 1, 4 is common. Next, anything else? 2, 4 is common. Next, anything else? 3, 4 is common. That's it. So the commons are 1, 4, 2, 4, 3, 4. Next, we will take third one. What is the third one? A cross B union C. So first I will write A, then cross B union C. I'll take B, then C. Now I have to take cross. That means first I have to start with A. That means first start with 1. 1, 3, 1, 4, 1, 5, 1, 6. Next I'll start with 2. 2, 3, 2, 4, 2, 5, 2, 6. Next I'll start with 3. 3, 3, 3, 4, 3, 5, 3, 6. Done. Fourth one. But fourth one, again, I will write A as 1, 2, 3 because we can't go to the previous page again and again. B is 3, 4 and C is having 4, 5, 6. So the fourth one is you have to find A cross B union A cross C. So first I will write A cross B. I'll start with A. That means I'll start with 1, 2, 3. And B I will take 1, 3, 1, 4, 2, 3, 2, 4. Then 3, 3, 3, 4. That's it. Union A cross C. I will start with A. That means I will start with 1, 2, 3. And I'll take C also. So 1, 4, 1, 5, 1, 6. 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, 3, 6. Now I have to take union for both the sets. So union means whatever is there in first set, I will copy. 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Now I'll copy the second one. 1, 4 already written. So I'll write 1, 5, 1, 6. 2, 4 is already written. So I will write 2, 5, 2, 6. 3, 4 is already written. So I will write 3, 5, 3, 6. These all come under union. Okay. Until here we have done. The next part, some more examples and then exercise 2.1 we will do in the next class. So with this, I will end the class. See you in the next class.